Hello everyone, it's August 25th. Alright, let's get right into it. Sum of square numbers. Given a non-integer c, decide whether there are two integers a and b such that a squared plus b squared equals c. Okay, isn't that the Fermat theorem, right? Because it's been proved that larger than squared is not going to work. But this is the triangle, right? What's that? Pythagoras theorem. I have a different name for different culture, but Pythagorean theorem. A squared plus b squared equals. Actually, it's not. That's a squared plus b squared equals c squared. But all we want right now is equals c. So no. That's completely different. I don't know what I was thinking. No, it's completely different. Let's just say, given a c, if it can be the sum of two square numbers, and that's it. Okay, and non-negative integer c. So I think we can. Maybe there's some math solution for this. A squared plus b squared equal to c, right? And we know that c is a value. C is some value. I mean, and all I want is a true or false, right? All I want is a true or false. Let's see, a equals c minus b squared. That's not helping. That's not helping. So we have a c, right? So a and b, well, definitely, I mean, b squared is 0, right? So a will be smaller or equal to square root c, and we can consider both of them positive. So be 0 to square root c, and so is b to square root c. So by doing that, we get a range, right? We get a range of a and b. And then, we have to square it anyway. So, I mean, isn't this like a two-sum problem, right? It's a two-sum, but instead of two-sum, we're two squared sum, right? So, again, we can choose to use two pointers, right? So we have 0 to square root c, and we'll take the floor of square root c. So let's say we call it k, right? So from 0 to k, we can put a at one end, b at the other end, and then we do it. If it's too big, then we move a. If it's too big, we move b. If it's too small, we move a, and then we can gradually go into the middle. And once we find one, we just return. The worst case scenario will be ON, which is 2 to the, so not 31st, because we do a square root. So it's 2 to the 16, 2 to the 16, 2 to the 15. How much is that? 2 to the 16th power. It's not too big, like 2 to the 16, 65536. That's the, and actually, yeah, that's the most we're gonna have to handle. So yeah, we can try this. It will be O ON. Well, I mean, we know, and we can call it O1 because we know that's not gonna exceed a certain value, right? So we can call it O1, no problem. But all right, it's just, what did you do, man? I think I copied it. Yep, I copied. It's so stupid, man. Don't be so stupid. I did it again. There we go. All right, so we need math because we need k equals, that's called and, right? And let's do this. A B equals 0 and math.sqrt c, and then we take an int, which is same as floor, right? So I'm going to say while a is smaller or equal to b, because they can be the same, if a squared plus b squared, right, equals c, then return true. And if a squared plus b squared is smaller than c, that's too small, so a plus equal 1, else b minus equal 1. And then return false at the end. So basically we try out every single value in this range, and then alright, let's see. 5 shall be true, right? 3 shall be false. 4 shall be true. 2 shall be true. 1 plus 1, and 1 shall be true. Right, so this one passes C. This is going to be judge C. Wait, what? What? He? Oh, nice. By how much?
From 55 to 29.
55 to 29. Wow, cut a half.
And because a new law allows more people to qualify for paying for.
Ah, so pool is bigger. Oh yeah, nice, good.
55.
Yeah, yeah. He still blundered in the Afghan retreat though. But this is he did good things and he did bad things. I mean, the whole Afghan debacle is just 20 years of debacle. Every single president is to blame. All right. Anyway, so we passed. Should we say so? This is basically a two-sum problem. Two-sum problem dressed in squares. All right. We first find the range for A and B, and then use the two-pointer method to squeeze, squeeze closer to the solution. I'll call it O square root C, right? O square root C. That's the runtime, O square root C. Let's see if it's fast. If it's not fast, we have to figure out a new method. Yeah, it's meh, 528 milliseconds, which means there are better solutions. 7% ranking. Why'd you got 6.7? Just 17% ranking. That's it. So we see two peaks, right? 2 peaks. So supposedly there should be 2 better solutions. All right, let me think if I can. I mean, can we jump a few numbers? We'll basically have to compute the square root for every single one of them, right? I feel there should be like a more mathematical solution to this. Whether it's doable, right? That's the only question, whether it's doable. A square plus another square. That's the same thing. I mean, we can use a trick, right? We can use a trick because C is this. We can just compute. We can literally compute the square root of all numbers from 0 to this thing square root, right? When we compute all of them, we have 65536, so 65,000. Only 65,000 values. We put it in, and then we, oh no, now we have to generate the, oh, it's fine. We just compute that, make that into a, no, it's not gonna work. What else can we do? Some square root of some plus another. I don't know. Interesting. I don't know if there are any better solutions except for this. I think we might consider, can we skip? Like instead of plus equal 1? Maybe we can skip. Let's say too big or too small. We can compute how much big and how much small, right? Maybe based on the amount of deviation, we can skip more instead of just do one by one. Let's see, if they say start and end, is too big. Let's take a look at 5. 5, square root 5 will get 2, right? So we get 0, 1, and 2. So we start from 0 and 2. We add up to 4, and that's too small. We move A. But that's 1 small. So every time we move to the next value, how much do we get? So 0, 1, and then 4, right? So from 1, moving to 2, we'll get 3 additional. I don't see how this can help. Binary search? It is sorted, right? How do you do binary search? We go in the middle. It's middle plus, you don't know that, right? You don't know that. I don't know. I gotta check. What are the better ways? Brute force. Now we are slightly different. This is OC because it looped both ways. So let's see what this 633. Now ours is slightly better than brute force. What is this? Log C. Now ours is better than this. I don't understand. What is this one? Over the range? Only if we consider that. Expanding b square value, check if it is a perfect square or not. The square of nth positive integer can be represented as a sum of first n positive integers. I would check for, okay. Square root function. Iterate over this, that is by choosing a. For every a chosen, we find square root. Takes log c time. Binary search. Fermat theorem. Yeah, why not two-pointer? Two-pointer is just logs. Yeah, it's O square root c. That should be the fastest method. Anyway, how is this one slower? This is log c. Log. Oh. Okay, this one, square root c is log c. Now log c is smaller. And this is, yeah, this O square root c, which should be faster than all of these methods. I don't understand. All right, binary search. I just read the code. Okay, this is binary search. Then we go, so b minus this. And then we search it. Yeah, that's just stupid. All right, you're stupid. You don't have to do it this way. Because you can do it easier by using two pointers. I just use binary search to decide whether we can find the values in it. Yeah. I think this is the start. This is end. This is the current value, right? So wait, what we're trying to find? We're trying to find whether a value exists from 0 to b, right? So we'll try to find whether b is a perfect square. How would you do that? What is this one? It's still long. Any positive number n is expressible as the sum of two squares if and only if the prime factorization n, every prime of the form occurs an even number of times. All the prime factors of the given number. If and only if the prime factorization of n, every prime of the form 4k plus 3 occurs an even number of times. So we find all the prime. To division, if at any step we find out that the number of occurrences of any prime factor occurs an odd number of times. At any step, we find out that the number of occurrences of any prime factor of the form occurs an odd number of times. We can return a false value. won't be divisible by any other prime, so check C can be expressed. So return false. Return true value. Alright, so we need to first find the primes, right? So I have a count. This, while this count, divide, and then get out. We try to see if this is this and count is odd, but return false. Otherwise, we keep going. I don't understand. They never mentioned the two-pointer method. Hash set, yeah. Just basically put everything in it. Yeah, this is a two-sum problem. Yeah, that's a two-sum problem. All right, that's it. Two-sum problem dressed as a square. And I think the official solution, I don't quite like the official solution. They go too complicated for this. Anyway, that's it for today. See you guys tomorrow.